In this video, we're going to evaluate the integral of log to base b of x. And because the base b is not given, what we're actually doing is deriving a formula for finding the integral of any log expression that has this look. You just plug in the base, whatever you're working with, and you have the solution. If you want to give this a try, go ahead and pause the video, and I'll be right back. So what I'm going to do here is I'm going to convert this integrand using the change of base formula. I have the log of x to base b. I can pick any other base. So I'm going to pick natural log. So it's going to be a natural log of x over the natural log of whatever this base is. In this case it's b. So this will be b. This will be 2. This will be 2. 3. We put it 3 here. And this is dx. So it's just the same integral, same integrand, just use the change of base formula. Now what I'm going to do, I'm going to factor this 1 over ln of b. That's a constant, so I can bring this outside the integral. And that just leaves me with ln of x. And then we can use integration by parts here to evaluate this integral here. So I need two parts, a u function, which will be the ln of x, which I can differentiate, and my dv would be 1 times anything is that expression, so I'm going to use dv to be, we'll let dv equal to 1. So those are the two functions, ln of x and then a constant function 1. So du will be equal to the derivative of ln of x, which is 1 over x. This will be dx here. Here this is dv equal to 1 or dx here. 1 dx, so we integrate both sides here. V then is equal to x. So I got a constant 1 over ln of v. And then we're going to integrate the natural log using the integration by parts. It says the value after we do these calculations, the first part of the answer is the u times the v. So we got u to be ln of x times the v. I put the x out in front. I got this, x times ln of x. And then the second part, it's minus the integral of v, which is x, times du. I'm going to have v, which is x, times du, and du is 1 over x. dx. Now this is going to be a simple integration here because this is going to cancel here, x and x are going to cancel. So I'm going to have the integral of 1 with respect to x, which is going to give us x. So all we got then is x ln here of x minus, and like I said here, I have the integral of 1 with respect to x. That's going to give us x plus the constant of integration. And this is pretty much the answer here. But if we want to get it back in the original form here, we can do this. So let's rewrite it. We're going to multiply through here. We'd have an x here, and then this will be ln of x over ln of b. And this is going to be, again, all I'm doing here is distributing this constant here in the parentheses. This will be x here and here. So x over ln of b, and I got the constant of integration. But this part right here, when we started off, that's where we introduced the change of base formula. So ln of x over ln of b, that's the log of the original expression of x to base b. So this is pretty much your answer right here. So anytime you're given something like this one, the log, integrate the log to base b of x, that could be a base 7, base 2, then you can do this process every time, this procedure, to get the answer. So So if you got the integral, say, log of x to the base 7, then you'd give this exact same thing here. So if we have a b, you put the 7 there, the first expression there, and then here, constant of integration, and you have it. So this is actually a formula that you can use to find the value of an integral, indefinite integral. Again, just plug it in the base value. Thanks for watching. We'll see you next time.